Okay, today in class we first went over, we went over 3 different rules is what we were trying to get to. So we got to the first 2, and I'll just quickly review those, and then we'll go ahead and do the other ones, do what we didn't get to, so that we can be all the way caught up. So we've talked about if a degree, if a numerator, we're talking about rational functions, so if the numerator of that rational function has a degree of n, the degree of the numerator is less than the degree of the denominator, so the degree of the top is less than the degree of the bottom, then the rule of the horizontal asymptote was at y equals 0. Now, the reason that is, for example, if this right here was, sorry for bumping the camera, if this was, say, x over x squared, then what that would do is that would actually equal x over x times. So if we actually divided that, we could simplify it out to this, x over x times x, which equals x over x times 1 over x. So then that would just simply be x, this side would be 1 times 1 over x. Now is that then the question is, what is the end behavior of this? So as x goes to infinity, then 1 is divided by a bigger and bigger and bigger number, and that's going to make it get closer and closer to 0, but never to 0, because 1 divided by any number is never going to be 0. It's just going to be a super tiny small number. Now the same thing is if x goes all the way to infinity, negative infinity that is, if it gets bigger and bigger negative, super and super, more and super negative, then you're going to just get the same thing. It's going to get smaller and smaller and smaller, never 0, but smaller and smaller, but it'll eventually get to 0. So that's true for anything that the numerator is less than, the degree of the numerator is less than the degree of the denominator. So this isn't actually a technical way to write that. I just decided to write it that way. It's a little bit, it's less to write. So that's not an official writing by any means, but it's just a little bit of a shorthand there. So the next rule is degree of the numerator equals the degree of the denominator. So then the rule for that horizontal asymptote is the fraction of the leading coefficients is what it approaches. So y equals the fraction of the leading coefficients. Sorry if that's spelled wrong at all. Okay, so for example, if we had or let's just do an easy one first. Let's just do x over x. Well, if you divide those out, that's just going to be 1. No matter how big this is, that's going to be just as big, positive or negative. So if these were both negative, then it would be negative divided by negative, which would still be 1. So if there's no coefficients, then we know that they're really 1. So 1x over 1x equals 1. 1 divided by 1 is 1. So it's going to be 1. Another example would be if it was just 2x over 3x. And so if that was the case, then we could simplify that. I'm going to make this a little smaller. We could simplify that to 2/3 times x over x, which would then simplify just to 2/3, because x divided by x is what? It's 1. So 2/3 is what you're left at. So if the degrees of these are the same, like this, the degree of the numerator is equal to the degree of the denominator, then this will always go out. That's even true, like we talked about in class, that's always true even if there's a bunch of other things. So if these, say these were like x cubes, and this was some other stuff, plus x squared, blah blah blah, and this is 2, the extra stuff would be dwarfed compared to those leading, the variables with the highest power. So we concentrate right here, and that's actually what it's going to get approached to. So then the last one that we need to talk about, which we covered just a tiny bit but not really in detail, so is when the numerator, the degree of the numerator is greater than the degree of the denominator. the rule for that, I'm just going to give it out and then we're going to talk about it for why that is y equals the equation after division. Actually, a better way to say that is the quotient. So I'm going to erase that real quick here. Meaning the answer that you get after you divide. So the quotient so y equals the quotient, and we don't even care about the remainder. And I'll show you why that is true in a second. So the quotient minus the quotient. Oh, sorry, the remainder. Okay, so for example, if we had this, which would be x squared plus x minus 3 over x plus 4. So this is the degree, so that's a second degree polynomial, and this is a first degree polynomial, so this is actually true. The degree of the numerator is greater than the degree of the denominator. So like this says is go ahead and divide it, just like we did up here, just like we did down here. We actually did the division and saw what we got. Here it's approaching 0, this is actually approaching a number, and then this is what we're actually going to be checking is what we get. So first I'm just going to do the division real quick. So slide this up just a little bit so you can see for sure. X plus 4 and let's see, maybe I'll slide that down just a little bit. X plus 4, x squared plus x minus 3. So we see what this x needs to do to get into this first thing. Well, it needs to be squared, so we're going to multiply it by x. So x times x is x squared. X times 4 is 4x, so that's a plus 4x. And is there a 0? So there's 0 over here, so I'm just going to put 0. It's a little bit easier to keep track of everything. So then you subtract, and you say x squared minus x squared is 0. X minus 4x is negative 3x. And negative 3 minus 0 is negative 3. So then we say, how does this go into there? Sorry. How does this go into there? Well, we need a negative 3x. So I'm going to put negative 3. And negative 3, because that negative 3 times this is going to give us that negative 3x. Negative 3 times 4 is negative 12. Then we subtract. After we subtract, this goes away, and we get, because really it's negative 3 plus negative 3, or sorry, negative 3 plus 3x is going to be 0x. And then negative 3 minus a negative 12 is actually going to be negative 3 plus 12, which is going to be 8. Did I do that right? No, it's going to be 9. It's going to be 9. Okay? So, just like this, and this will not go into that. So that says that this is our quotient, and that's our remainder. So normally we could write remainder 9 out here. But, and hopefully you guys remember this, if you take that 9, all you have to do to get it to be your answer is take this and divide the 9. So what we could do is rewrite this equation, our answer I should say, or our quotient as x minus 3 plus 9 over x plus 4, because that makes sense. You got this remainder, and it was not divided by this, so we need to remember that it should be divided by that, so that's going to be there. But look, this looks a lot like this up here. Maybe you can't see that. This down here looks a lot like this first one. The degree on the bottom is greater than the degree on top. Or I should say the other way. The degree on the top is less than the degree on the bottom, and so that is going to go to 0. It's always going to, this will always reduce down. As x goes to infinity, this will always go to 0, just like our first case. So that will always be true for our remainder. Even if it's a greater polynomial, even if your remainder is not just a number, it could actually be a polynomial, that will always be true, that this bottom will always be greater than the top. So this will always go to 0. So you can safely say that just look at the quotient, like this rule says, just look at the quotient and minus the remainder. Maybe I shouldn't use the word reminder, or minus, I'll use the word ignore. So ignore the remainder there, because that will always go to 0. Okay. Go ahead and watch the next video.